Hi, good evening once again. Back to our first normal broadcast of the Meteorology Lab channel. And a bit of a weird sunset this evening. Looks like a little bit of smoke or maybe haze. I don't know, it kind of looks like smoke to me. I haven't really checked it out yet, but also got Venus and the moon out there. Looks like a first quarter moon out there to the southwest. And yeah, let's check on United Airlines 437. I happened to see that when I was out there filming the sunset and just now getting into Denver right there. It's amazing how fast these planes move from one point to another. I spent like 2 days driving up to Denver just a couple weeks ago, and this little plane gets up there in the time it takes for me to set up the webcast. So anyway, for today we've got a pretty nice day here in Texas. It finally cooled down a bit, and you can see that we've shoved a lot of the tropical air off to the east. Unfortunately, not without severe weather. We had a little bit of an outbreak in Illinois, parts of Indiana, and actually even up to Michigan last night. And I've got a couple of archived frames here. Let me switch over to my GR level 2, and we'll bring that up real quick. And before I get into too much detail on this, let me check on the audio and make sure we're all okay. There's always a few snags coming back from vacation, stuff like that. The meters here, they look pretty good to me, actually. Maybe running a little bit hot here. And I'll go over to the chat here and see who we've got. We've got Andrew checking in here. First one on, Kevin McKinney. Fred Reamer up in North Dakota. Fun with Tech is here. Michael Burrell 13. Sue M up in Indiana, weathered the storm. Ron Chalfont in South California. Appreciate it. And Mark Davis is here. And Fred Reamer says 5x5 on the audio. So this was one of the severe storms we had last night. This is in Illinois. So we're looking at the Crossville area, and you can see I've put a dot right there. This is one of the properties that got hit, and I think I may still have that up in Google Earth. Let me switch over to that real quick. Yeah, this is actually the house that got hit last night, and you can see it's out there in a farm area, and it's just southwest of Crossville. So a lot of times I'll go into the reports and check that out, because the position of the damage is actually kind of critical when you're kind of reviewing a severe weather case. You want to kind of relate that to where the town is. And so we know that that's about maybe 1 or 2 miles southwest of Crossville. And so that's why I put the dot there. So what happened exactly? Well, we've got this large storm here. You can see that that's kind of a tail end storm. Maybe some weaker cells up to the northeast. And we started out at, this is going to be about 9:55 p.m. This is around the time we went on the air, actually. And you can see that little hook right there in the southwest part of the storm. As we move forward, sweeps right over that farm right there. You can see the inflow area right in this area here. Looks fairly clear. That's kind of where the rain-free base is, right in that area. Then as we advance forward to 10 o'clock, then 10:02, now we can see a little bit of a debris ball right there. Then I'll move forward a little bit more. You can see that kind of becomes even more strong there. Didn't show up so well when it was over the farm where that fatality was recorded, but later on as it moved towards the river here, I forgot what river that is, but it becomes a lot more prominent, crossing over into Indiana right there. Let's run that back, and let's try looking at the storm at the spectrum width. And this is a measure of the diversity of velocity in each volume gate. So if we are seeing a different velocity motion in a certain gate here, the greater the difference is, the greater the diversity, the higher the spectrum width. So we're going to see that when we have a lot of debris in the air, when you have lots of sheet metal and nails and precipitation, that kind of thing. Well, at this time, the storm was down in this area. Let's check that. Let me flip over to reflectivity. Yeah, so we're looking in this area right there. And moving on over to spectrum width, doesn't show up so well there. And then we move forward in time. Still not showing up very well. Even over the crossfire area, looks like maybe that's picking up right in this area here. Still not really showing up. Yeah, so that's where it is right there. And so it looks like that spectrum width ball has kind of appeared there, coincident with the reflectivity data. So then we get a little bit of range folding in there. Actually, I think maybe I skipped ahead there. Actually, there's a spectrum width debris ball right there. Let me try moving that forward. Okay, so you see it right there. Then it's here. Then it's here. So not a whole lot of help there. But let's try going over to the storm relative velocity image. So now we have the velocity signature here. Looks kind of like a spread out couplet here. We see some outbound velocity here. Let me double check that. Yeah, this is going to be inbound to the radar like that. We have to keep in mind that the radar is this way. We're looking towards the Evansville radar. So here we have a little bit of inbound, and then here we have a little bit of outbound, and we're talking about on the magnitude of maybe 60 knots outbound. So it is kind of spread apart, and there is a lot of range folding. So we're not getting a very good look at this storm here. We're on the 0.4 degree tilt, and we'll move forward. Storm is approaching the property right there. Still, it looks like not your classic TVS signature, kind of like a velocity signature kind of spread apart here. I'm trying to get my tools to come up. I think they might have crashed. Let me see if I can bring that up again. No, looks like it's still there. Okay, here it comes. So there we go. The couplet is kind of spread out. And then I guess as we move forward, we're going to see that really come together. Yeah, so right after it passes the farm there, now we see it coming together. Classic TVS right there. 91 in, 69 out. So that came together really quick there. And I think the data was pretty severely degraded by that range folding further back there. So it might have actually been hidden in here. Then as we move forward, still pick it up right there, and then it gets, well, looks like we pick it up for one more frame, then it just gets kind of lost in this mess there. But you can get some help by looking at other radars and also other tilts. So I've stepped up to 0.8, run that back. Don't have very much data at 0.8. Yeah, so this wasn't the optimal situation here for sampling it via radar. But we can see that the magnitude of storm motions, this is up at 1.2. You can see very strong outbound. There's 48 to 50, even 60 knots outbound right there. Very strong inbound, so that would pretty much clue you in to maybe putting a tornado warning out with that kind of storm motion within that cell. Okay, then I'll take you to one other storm that was further north. It happened earlier in the afternoon, about 4:30 to 4:50 maybe. I have to go up to the Davenport radar for that. And that's the Ottawa storm, which is just southwest of Joliet. We'll wait for that to come up here, and while that's coming up, let me just take another look at the chat here. Victor Cabot, greetings Tim, audio a little hot. Yeah, I do see a little bit of red here, so maybe I'll just take that down just a little bit there. Bring it down about 4 decibels. Sarah Wood saying hello. Mark, good evening, Tim and chat. Kevin McKinney says the 1925 tri-state tornado passed through the Crossville and Carmi area. Had no idea. And Mike is suggesting a sounding and hand analysis refresher. Yeah, since we're heading into March, that's probably a good idea here. Especially with the Denver conference being over and all the travels being over, I'll probably be able to start concentrating on those workshops here. Okay, so now we're looking at northern Illinois. There's Ottawa right there. So we're pretty much north of Bloomington, south of Rockford, kind of in this area here. And this is the other cell that had a fatality. This particular fatality occurred on State Street, which is kind of in the south part of Ottawa. So we're talking about this area right here. I'm going to put a marker. And I'm not too sure that that was actually in the debris cloud or in the tornado. That was reported as a tree falling on a house there. So this could have definitely been an RFD type situation. I don't have the Joliet radar, unfortunately, because it just wasn't available, so we're having to use the Davenport site. So we'll just take what we can get and run that forward. We can see a pretty good classic supercell off to the west. And stepping that forward, I need to take that down to 0.5. Let me do that. Okay, so there's our supercell off to the west. You can see the updraft area kind of in this region right here. Remember, the updraft is not necessarily, in fact, it rarely shows up on the reflectivity. It's going to be mostly rain-free, and that's why we call it the rain-free base. So we bring that forward. Storm heading for Ottawa coming in here. This is 2240. Then we get a 2245. Now we see that closing in on Ottawa right here. Don't see a really classic hook here. And we are sampling this out, let's see, probably a good 80 miles from the radar maybe. We are up at 8,500 feet, so this isn't really optimal either. And we bring that forward and we see the core kind of over Ottawa. So it is a little bit tricky using reflectivity to see what's going on. So let's take a look at spectrum width, see what that shows. And we see, yeah, maybe something here. This could be maybe a debris signature. And I'm going to move that dot over here to the center of this just to see if it correlates to anything. That's probably about where we would expect some debris. Is that supported by the velocity? Yeah, I would say so. Let me switch over to storm mode of velocity. Yeah, that's this does look like a TVS in this area. And let's run this forward. Okay, we've got a missing frame there, and then we move forward a little bit, and I'll zoom in really close on this so we can really see this. Remember, State Street, where that fatality was right down here, south of this junction. So about right there. So it does look like maybe the TVS is a little bit north of there. So I'm going to put that little dot there. I'm seeing outbound velocity right here. The radar is off that direction. So this is motion like that. And then north of that, we've got inbound here. So this is the kind of rotation we've got right there. Then we run that forward one frame. Range folding comes back to haunt us, and we lose it right there. So what's happening exactly? Well, we're up pretty high in the storm, so I'm not really too sure. Here we see maybe a TVS right in this area here. So that's kind of a good question. I think for this we would have to wait for the Joliet data to come online. This also could be a cyclic transition here. So maybe one cell going up to the north and a new one developing. That's always a possibility. So I think on this one we would have to just say the jury's out and wait for the Joliet data. But let me drop this right here to mark this TVS, and we'll go back and look at the reflectivity. And we can see that's pretty well embedded in this. But again, we're up at 8,000 feet or so because we're pretty far from that Davenport radar. All right, so yeah, we did have other cells going on out there during the afternoon. You can see let's see, just northwest of Peoria, one tailwind storm. This certainly had potential, but I haven't looked at all the data. I'm not too sure what that did. Definitely had a supercellular look there as it went north of Peoria. So anyway, I think we're going to go ahead and head into tonight's data, since this is our nightly webcast and we just want to mostly take a look at the forecast and a little bit of the news there. And we see a little bit of a cool down across much of the central U.S., and we've got temperatures in the 60s for highs across Texas there, and dropping to the 50s and 40s across the northern plains. Also looks cool out west. And most of the warm weather we've got is over the southeast U.S. and that tropical air mass covering Louisiana up to the Carolinas. And we'll take a look at the 500 millibar chart, and we've got a trough over the central part of the U.S. So this we could probably consider our long wave trough. Main polar vortex over the Canadian high Arctic. You see that right there. And our jet stream is located from about Oregon down to the Four Corners, and then that picks up through the Midwest and up to Quebec, kind of like that. And I see probably a little bit of a trace of a subtropical jet through here, maybe a little bit of coupling through there from Texas up to Alabama to Atlanta. And the main subtropical high well to the south in the Gulf of Mexico down in this region. And we haven't looked at the 850 millibar chart too much. This is the Canadian analysis for this morning. But we can use this to kind of find where the 850 millibar front is. So we're probably thinking maybe from Oklahoma City up to St. Louis, then up to Michigan. So you can see that this definitely trailed pretty far behind the cold front, because by this morning we've had those storms go through the Midwest, and then the surface front pushed on ahead, and then you can see the 850 millibar front kind of lagged behind that. And we always find the upper fronts poleward of where the surface systems are. So the surface system was probably something like that, 850 front like that, and then the 500 millibar front would be something like that probably. And this is the water vapor imagery. We haven't looked at very much of this lately. You can see a little bit of the storm activity stretching from Louisiana to Virginia this evening. One thing that is kind of interesting is that as you go south, where you would expect the moisture to be out in the Gulf, it looks kind of dry. And why is that? Well, we have to keep in mind that the water vapor imagery is sensitive to the mid-levels. And so probably what we're seeing here is maybe there's some rich moisture in the lower levels, but the radiation... let me back that up. I don't want to get this too complicated. We would have to go back to the fundamentals of what we're seeing here. So maybe I should go ahead and do that. What we're actually measuring is not really the moisture directly. What we're kind of measuring here is the attenuation of radiation due to moisture in the atmosphere. So, for example, in the Canadian area right here, we're just not seeing any radiation from the ground up to the satellite. So it looks cold to the satellite. In Mexico, for example, the air mass is very warm. We know that, of course. If the air mass is dry, most of that radiation is going to make it up to the satellite, and it's going to look kind of hot. But if we have moisture present in the atmosphere, in fact, like you see here, that's going to block some of the radiation, and we're going to have kind of a cold signature. So when you see this cooler color, that indicates either that we've got moisture in the atmosphere or that conditions near the surface are cold. Now, let's see here. Let me go back to that image. Let's see here. Where do we want to go with this? Yeah. Okay. Sorry. I'm trying to get my sequence correct because we've been gone for a couple weeks here, and I wanted to cover the thermal analysis. I almost forgot that right there. Let me get that centered right there, and you can see the thermal gradient basically from the northeast down to Texas and Arizona there. So a lot of thickness packing from the south up to Canada, very spread out right there. So we do want to keep the front on the leading edge of that. Pretty easy to find the fronts this evening, so we're looking at something like that. It does get a little bit harder to find as we get out west. Probably an old front south of California here, and then we've got new frontogenesis up around Washington and British Columbia. So that's probably going to be our warm front right there. And there we go. New occluded front, new frontal system coming onto the British Columbia coast. Okay, then we'll take a look at the soundings real quick, and yeah, see, I'm getting out of sequence here. We've got storms out in the southeast U.S., and we should take a look at those. I don't think I have any charts up for radar, so let me go over to that. Yeah, looks like our flight is landed there, so let me replace that. COD radar, they're pretty good for a quick look at the radar. Then we go to NextRad sites, and yeah, you can see about 1,000 miles long on this line of showers and storms. Looks very linear here. Maybe a few cells that have a little bit of severe potential, like there and there, but nothing that looks supercellular through here. Going down to Alabama. Also looks very linear all up and down the line. Then we'll go down to Biloxi and Gulfport. Looks like our line kind of tapers out. The line has more of a... You have to forgive me, that noise back there. I've got a bug light in here because we've had a little bit of a ladybug infestation over the past few weeks, so I'm taking care of them. A few of them have sneaked in while I was gone, so I'm trying to get rid of those stragglers right there. Anyway, it's got more of a capped appearance along the tail end of this line into Louisiana, and as we go into New Orleans itself, I think we pretty much lose the tail end. Looks like one little storm here in far southwestern Mississippi right there. I'm not sure what town that is, but that's pretty much it right there. So we can take a look at the soundings real quick, and I'm going to go just ahead of that line to Tallahassee and see what the pre-storm environment looks like. It doesn't look like any particularly good loaded gun soundings. We can see Tallahassee here. We've got dew points in the low 60s, which is not optimal. Looks like that moisture kind of tapers away to lower 50s at about 4,000 to 5,000 feet, and then we've got dry air above that. So lifting that sounding there at Tallahassee with maybe a 77 degree Fahrenheit temperature. Doesn't look all that great, does it? So that's probably why the tail end of that line, that's probably why it doesn't look very impressive. And then we go to Lake Charles. Looks like a similar situation there, a little bit of rich moisture at the surface. Tapers out to dry air at about 850 to 800 millibars. So lifting this, I'm going to mix it a little bit and then go with 75 degree temperatures. Looks pretty capped here. Then not a whole lot of cape above that. So this isn't the best environment for severe weather here. Okay, we're about 25 minutes into the forecast, so I'm going to just kind of finish this severe weather part up and just look a little bit at the SPC products. Look at the dew point field from there. And our moisture axis, here's the 72-degree dew point. Here's the 70. So this right here is probably going to be our best moisture in advance of that line. So we'd be looking at the Pensacola area. And the other flip side of that, of course, is the capping. I haven't looked at too much of the capping, but we've seen that was a problem there at Charleston, and that could very well be an issue out in the western Florida Panhandle too. So anyway, I'm going to go ahead and head into the forecast here. Let me set up the GFS. And we can see that front pushing on off through the southeast U.S. Cold air advection in the wake of that front. And we see a bit of a Great Basin high across Utah and Nevada. So that's bringing a little bit of cold air south through Colorado. And looks like a little bit of a weak Alberta Clipper moving through Montana. So that's going to be that right there. Okay, so what happens overnight? Let's take a look, and we see things coming under the influence of the high pressure, and Alberta Clipper moves into Iowa by morning. Very weak there. And then by the time we do the webcast tomorrow evening, looks like what's left of that Alberta Clipper is showing as a little bit of a trough on the backside of that cold front. So maybe something like that there, and you can see a few snow showers associated with that in Illinois and Indiana. Main front well to the south. Then going into Friday, high pressure covering the Ohio and Mississippi River valleys. Lee side trough setting up in Colorado. So we're going to see a little bit of a warm up in the plains through here. New Pacific system coming on shore. It's kind of off in the corner of your screen. And then for Saturday, looks like that Pacific system kind of moves inland a bit, and there's probably the cold front probably looking something like this here. And I see a little bit of interesting pattern there in South Texas. Looks like maybe some sort of easterly wave or something coming up on shore here. So we'll have to take a closer look at that, I guess, on tomorrow's webcast. We can see this is probably mostly an upper level pattern, because as I move this forward, it looks like it's originating from the Pacific and moving eastward. Maybe a little bit of isentropic lift on top of the cold dome here. Maybe that's what's going on here. But it looks like whatever it is breaks up by Sunday. Anyway, for Sunday and Monday, it looks like that Pacific system kind of crosses the mountains right there. You see the banding right here with that front crossing over. Probably a little bit of a downslope day in Texas and Oklahoma. And that emerges on the plains by Monday night. And it looks like we got a pretty good cold push as that moves eastward. Kind of undercut, looks like, by a pretty strong moving Canadian front coming south from Canada. That happens pretty quickly on Tuesday. So we go from that Monday night. By dawn, looking like this, very fast progression of the patterns. And then by Tuesday night's webcast, everything is pretty much offshore like that. And the 540 line coming all the way down to Oklahoma City, down to St. Louis and Chicago. And as you can see, that pretty well demarcates the limit of wintry weather. Kind of divides it pretty neatly between winter weather here and liquid precipitation on the other side. So it looks like kind of cold around the midweek, and then by Thursday and Friday, things kind of moderate. Not much else going on. Maybe one little one little Canadian system moves south. That's mostly going to affect the Great Lakes in this area here. And then by, let's see, 15th and 16th, looks pretty quiet here. Maybe a couple more weak Canadian systems coming southward. And that's about it there. Don't see any severe weather on the plains. We are getting into that season, but looks like not much in the way of chase prospects maybe until later this month. All right, well, that's quite a bit there. I'm probably boring a lot of you. We're 30 after, so let me go ahead and just wrap up here and take one last look at the chat. Pretty lengthy chat here, and let me just kind of skip through. Jeff Lockwood mentioning his dew point in Tallahassee, 69 there. And let's see here. Okay, a little discussion about my books, and okay, that's pretty much it. Anyway, I appreciate you joining the webcast. I hope you all enjoyed that. If you have any suggestions, head to weathergraphics.com and send me an email and let me know, and we'll see if we can work that in. You know, we've had one suggestion to do the workshops, and I'm going to try to get to that now that the convention thing is finished. Anyway, we'll see you all tomorrow, and I hope you all have a good evening. Thanks.